Welcome to today's session. This is the second part of the Wazuh webinar series. This one deals with creating the decoders, the things to look out for, etc. I've had to condense quite a bit of knowledge into an hour session. So you will notice that I've pre-created some of the items just to stay within the time frame, but additional information is available and any gotchas will be discussed as part of today's session. So let's get started. I'm the presenter, Louis from SIEMonster. From the sales side, we've got Mandana as a panelist. So if you have any sales queries, you can speak to her. And from the technical panelist side, there is Chris Rock and Jim Bycroft. Okay. When creating decoders, the first thing that you need to remember is don't rush. A lot of the decoders is factored around regex and items related to regex, the matching of the data that you're receiving. And because there are lots of similarities between logs, even though they're quite different, there are similarities. If you rush your decoders, you may end up with a decoder that can match more than just your specific logs that you're looking for. It could introduce misdecoding of your events and various other items that could impact your end result that you don't really want. From a syntax point of view, there's full documentation available. I'll be sharing the slides after the fact with all attendees. And you can review the individual options on each of those URLs presented. Some things to note: the decoder syntax gives you multiple options for the decoders. It is quite important that you understand the functionality of these components, even if it's just to create base rules. What you can do is you can go into your existing decoders that you've got on your environment. You can look at the pre-matches or the right at the top, the decoder blocks there, and you can try and reverse engineer and figure out what they've done to get the data extracted. You will find that there's sample data right at the top as well, which will allow you to play with it yourself to create custom decoders and so on with the structured data that is there. And you can compare it to what's there and see maybe you would have done it a different way, because there's no perfect way to do this. It all depends on what your needs are and how you personally approach regex when you're extracting the data. Because this is XML structured with regex, unfortunately, it is not tolerant of any typing mistakes or typos or syntax mistakes. It is important to use some kind of coding tool like VS Code or even Vim on the command line, which will do syntax highlighting for you. It produces quite a bit of results when you have to troubleshoot the code that you've written or the decoders that you've written. That is very important because, as we saw in the first session, nobody's immune to typing mistakes. I made one myself, and it could cost you hours if you don't spot it early enough. If you're just using a text editor, it won't highlight the syntax, and you may very well miss an item. Something else to note is Wazuh has historically had a number of static fields. So these were fields that you would use to extract data into. You would map your log data and you would decide what parts of the log would go into one of these static fields. That being said, the static fields are still available, but the new approach is to use dynamic fields. So dynamic fields are any fields that do not match the names of the static fields. There are limitations to them. I would highly recommend you read the last URL on this page. That will guide you through them. One of the items, for example, on the static fields is that you can only extract 8 fields at once, and you'll understand why that's pertinent in a few minutes. So if we look at the data structures that we collected in the last session, you can see that the same data, just from a different data source, can look drastically different. The first one was a pure TCP dump of the data coming into the environment, and that is its raw and native format. And there may have been one or two characters before that that is invisible, but this is essentially what you can see on the screen. Now, if you look at the red parts on the first part of TCP dump, you'll notice that there is some kind of a timestamp. Then it tells you there's some kind of host information as to where it comes from. And then it gives you a direction indicator as to where the items are flowing to and what type of traffic it is, etc. So in this case, it was taken on the bare OS of the VM, so not inside the container. So, and that's why you see that it's forwarding it to ubuntu.local.domain.syslog, because the OS would have passed it on into the container after the step in the process. Now, we also looked at enabling a log all option in OSSEC in the previous session. And if you look at the data structure from those logs, you'll see that there is a piece that was cut off from the start. And it is all the TCP dump related information that has been completely removed. It still has a little bit of similar information that shows the directionality and the date and time, and also the IP that it was received from. And that's when the logs actually start, from September 30th at 31 minutes past 8. And that's the rest of the data to extract. Now, there's a secondary option that we also discussed last session, which was the archive.json, which will archive the data in JSON format. The benefit to JSON format is that it's very structured and it's very easy to work with. However, when building dataset decoders, it is not an optimal format to use because it changes the format that you're seeing inside the decoding part of Wazuh. Unless you're going to use the JSON decoder, which is relevant if you're picking up specific files like Suricata's output can be picked up by Wazuh, and that's in the JSON format. If you're using that, then sure, you can use the JSON format to test with and go through the process that I'm explaining. But alternatively, the most accurate one that you want to use is the one that comes from just straight up archive.log. So understanding the log structure is quite important. When reviewing the data so that you can start decoding it into attribute levels, you need to understand what the log is, what you're trying to get from it, and what the structure is inside the logs. Every vendor has their own idea of what logs should look like and what data it should have. Some of it's fluff, some of it's not important, some of it's just pertinent to the vendor. So it is important that you analyze the data to see what is important to you and for your needs. It is not necessary to extract everything from a log, especially if you're never going to use that, because any data extracted is data that will be stored if it matches your rule set, which equates to disk utilization. And on items like firewalls with full UTM licensing, etc., this could have a very serious impact on your storage capacity and the costs associated with it. So it is important to review that as well. Fields names after extraction. The topic that I raised with static fields and dynamic fields, you can see that static fields are limited to 8 simultaneous extractions. And that is pertinent if you use the old method of extraction. So the old method of extraction is where you've got one single piece of XML that is placed. You have one long regex string that basically takes the variables that you want and extracts it all in one shot. You don't split them out. There is a newer method where you extract the individual fields one at a time, which allows for much safer operation, and the chances of something going wrong is much smaller. It will also just impact that one field that you're extracting if you're doing the singular approach. I will show you examples shortly of singular versus plural. So once you get your data collected and you've established which logs are pertinent to you, which ones you want to extract data from, and what data it is that you want to extract from them, you can test what the decoders, the existing decoders in the Wazuh infrastructure will do with them as they are. Now, you will notice that in the first block here, I essentially copied the whole line, including that prefix part, and I pasted that into the decoder or into the log tester, and nothing matched. That is because it will only start processing it from this date forward. That is an important note to bear in mind. I have seen a lot of people get very angry after spending days trying to write a decoder and then realizing that they were copying too much of the starting data. So look for the starting timestamp. Alternatively, look just after where the timestamp would have been once you understand the log structures a little bit better. And you can see here that it starts there with the serial number for the device, in this case, that's sending the syslogs. You can see that once I copied it just from that date forward, it suddenly matched. It matched the incorrect group, which I've removed now. We'll discuss when problems occur later in the session. But just bearing in mind that it is important from which section of the text you start copying and pasting into the log tester. I will go through that process in an interactive shell in a moment as well. You will notice that there's a conflict with that. Please keep that in mind for a bit later. So your file locations are very important. By default, the provided decoders are in var OSSEC rule set decoders. .xml. That area is to be considered volatile. Anything you create there is going to be replaced if you restart the container. It will go back to the static defaults for that. If you want your decoders to be persistent, you have to place them under var OSSEC etc/decoders with the correct naming standard. The naming standard is a number of your choosing. It can be any number, but it is recommended to go to your existing decoders in your environment, look at the final number, and then add at least 100 to that, and then start with increments of 5. So if the last number of your decoders in your system is 800, then add 100. So you will start at 900. And then your next one will be 905, 910, etc. The reason is to leave spaces for that, because it can become important to reprioritize your decoders in the sequence that they're being processed, because they work on the number basis. I will show you. I'll give you a brief example of how that happens. This is also important when overriding existing rules, etc., or decoders. Okay, here is an example of an XML decoder block. You will notice that it's got a name at the top, and then it's got a pre-match, and then it's got a regex offset after pre-match. So it will first match whatever criteria you've specified in the pre-match, and then it will look for any fields or any collection of information that's further down the log that matches the after pre-match function. You'll note that there is a space in there. Sometimes it is possible to use a space, or sometimes you have to specify it. One of the URLs that I had on the starting pages included the items that you would need to look at for your building your regex and get used to. So if you wanted to specify a space, you can always just do \s, and that would indicate a space instead of leaving a physical space. There are situations where it's better to leave a physical space and other situations where it's better to just use the regex structure for that. It is a trial and error because it also heavily depends on the type of log that you're processing. It's important to use a structured approach. Once you've got your logs, you've identified the fields that you want to extract, you've identified what you want to name those fields, and now it's the process to get started. You can look at the existing decoders for tips if you get stuck on certain components. There are various approaches that were taken by various individuals, as the decoders that are in existence have been written by a large number of individuals. So the approaches are slightly different, and it will give you ideas of how to approach your specific log structure. Always make sure to open and close your XML structures completely and correctly. I have seen this time and again where a bracket, a greater than or a smaller than sign is missing, a forward slash is misplaced or exchanged for a backslash, etc. Syntax is very, very important. There are additional syntax options available if you want to play around with them, like the upper caret, which shows that this is the beginning of the text. You can also finish it off with a $sign at the end, stating that this is the end of the text. What to do when things go wrong? Look at the documentation. The documentation is constantly maintained, both from SIEMonster side as well as from Wazuh side. There is a lot of knowledge to be gained from those, and they will be your primary source unless you've requested professional services for decoders and rules. Look at your existing configurations. They will help you learn the process. They also facilitate practicing because of the data samples that are in there, and you can use them. They're freely available. Testing your regex. Sometimes you will find situations where a rule simply won't match. Test your regex. Use tools. There are many, many, many regex tools available online, as well as for tools like VS Code, where you can add regex workbench, and you can place your data in there and you can build the regex from there and test it to make sure it functions. The log test functionality in Wazuh, as good as it is for testing if your decoder is working, it will not give you in-depth debugging capabilities. And if you're working on very complex rule sets and decoders, you will need tools like that. So get familiar with those. You will need them. Conflicting decoders, as you saw in an earlier screenshot, in some cases, there are decoders in the system that have been written by others that is too verbose. The code that was used in the regex has too many options to match, which means they've either taken too little data into review for matching their pre-match, or it could simply be a case of the exact fields and lengths, etc., come from them. It has been seen on Cisco decoders. It has been seen on AV decoders where developers switch between companies and they use the same format at the next company. These things happen. If you have a conflicting decoder, first things first is to see what is in the decoder that is matching your data better than your decoder. Secondly, move your decoder's numbering to within the range of the, or before the range of the conflicting decoder to see if that resolves the issue. Alternatively, if you're not using the conflicting decoder, you can always remove it, bearing in mind if you restart the container, you have to remove it again. We'll get to the questions in a second. What I want to do now is just run you through some of the command line options and examples. If you have any specific questions that you want addressed now, feel free to ask, and we can have a look at those. Okay. So First things to remember is, I'm just going to go back in my notes because there were specific things I wanted to show you. You will notice that I've created the skeleton framework for a decoder already. I've got my log samples at the top, and they're commented out in XML format. That way you can include them. It's important to include the samples that you were working off when you create decoders, so that when somebody comes afterwards, you may leave your company, you may retire. There could be various reasons. If you leave it in a way that they can look at the data that you were reviewing, they can compare the data or the source, and they can then see if there's been any changes after firmware updates or software updates that could require an adjustment of the decoders that have been created. The rules will pretty much be static in that concept because you won't change the attributes that you're looking at for the rules, but the decoder that has to translate a solid line of code into this various attributes would require that you might have to do some adjustments there. So let's use the last line as an example. And you'll see that I use log test quite often. Log test allows me to see how my items are decoding. As you can see, I've copied the entire line and there's no matching. But now I take that portion and I paste it again, and now suddenly it matches. So that was to demonstrate how that first piece is ignored by the log test functionality. It's just something to bear in mind when you test. I've seen quite a few people pull a lot of hair out when they forgot about that. So to give you an idea, you can see that the interface has been extracted from here, which is there. And you can see that the decoder is matching UDM. And let's have a look at why that is matching. To get out of that, you just Control-C. You go back, and you can see, if you look at the log source, you can ignore that first part. So if you look at this, timestamps, etc., is generally considered normal. People can extract that very easily. The system has many permutations where it can match those. So you would essentially also ignore that when you start writing your decoder. The important part is after this. Now, if you look at that line there, you'll notice that the character count is 12, and there are 12 of these items here. Now, /W is A to Z, uppercase and lowercase, 0 to 9, hyphen, at, underscore, essentially anything except a space and weird characters like hash or asterisk, etc. So that means that it will basically match any string coming into the system that has a sequence of 12 characters that falls into that category. This is a very poor decoder. That piece there comes from the semantic one that you saw in the slides, where it would decode the semantic AV items. Now, a better option would have been to expand on this, where you would, for example, add the items that come afterwards, like you would add the comma UDM dash or hyphen in at the end of the W here. But you have to play around with the regex to see what will match and what won't. In some cases, certain combinations simply won't match. And that is a trial and error situation. Even though you're sticking to the rules, they may still not match because logs can use funny characters that's in a different format, like Unicode. And what looks like a hyphen to you may not actually be a hyphen. So when you're working with the actual strings that you're matching, you also have to copy and paste them. Don't try and type them out. Copy and paste them and then split them out from there. That is very important. That was a harsh lesson that I've learned while creating quite a few decoders and rules. In this case, you'll see that there's just a firmware version for mine. So you can add that in well as well. So what you could, for example, do, and this is just an example of how you would edit it. You select it and copy it in Putty. You just select it and it will copy. So what you can do to place that as a regex is these three letters and the hyphen would pretty much be static, and the comma would be as well. So in this case, you would replace the one with D plus, which means that it would be a digit. You do D plus because that will match one or more times. The reason for that is vendors, they think they're funny sometimes. They'll increase the count from 1 to 12. And then if you have just one for \D, it won't match any longer. So if they're using a numerical system there, it's better to just make it a match once or more. Same with this one. And same with this one. Now you'll see the last one is 4. So you don't need to do that 4 times. You can literally just do that. And you can add that in and you can test it. Still guarantees it will work. There could still be funny characters in there, but this is generally the approach that you would use. So what we do is we paste that in there and we remove that unnecessary line and we can test it. So we copy our log and we write in quit log test, and it still matches. So that means I am literally matching this entire section here and moving forward from that. So this means I won't create a conflict with another decoder, because the chances of another log having that exact structure at the length that I've gone for is it's almost impossible. It's not completely impossible, but it's much more unlikely than just the original regex that was provided by the semantic AV1. We can go on to the next part now. So you'll see that we've got all of this now, and we now are interested in the rest of the items that's available there. So what you can do is you can look at various options. So let me just show you. So these are the volatile ones. You can see there's quite a few there, and you can see that they're neatly incrementing with their numbers. There might be more or larger or smaller gaps at some points. This is due to updated rule sets that have been released over the years. So we're dealing with a syslog from a network piece of equipment. So what we can do is we could potentially look for Cisco. So there's Cisco iOS. And we can look at what's included in that Cisco iOS for extraction to give us an indication of something that we would be working towards. So you can see these are quite static in their approach, and the structure looks nothing like the one we've got now. But you can have various options available that'll help you to extract the information that you need. There's many options available. You can pick them randomly as well, or if you're going through the documentation and you find something like parent, for example, the parent is an option that you can choose. You can grep for parent through these rules and see if there's somebody else that has created regex that is similar to what you want to create and how they've achieved that. If we go back to our decoders, and we'll quickly add another one here. So we want to proceed. So you can copy and paste this entire line or piece of code, and you can remove the items that isn't pertinent for your next match, because you've already matched it as UDM now. So now you need to match the next piece of information that you want. So if you go down the line, you'll see that after all the initial information, that's the interface that was using where it came in. And that's the outbound. So we could essentially go and edit this. We can call this the inbound interface. You will notice that I'm using dynamic field names. The order grouping is the specification of the field names. And you'll see that it is based on where your brackets are. If you have multiple ranges of brackets, so for example, the old method of doing it, where it's an all-in-one, you would literally copy that entire string into this pre-match or regex, and you would add your brackets where you need them, replace the characters with the regex equivalents, and you would then have all of your attributes specified at the bottom, split by commas. I'll show you an example of that shortly. So in this case, we've now got the inbound interface. So we'll switch it to outbound interface, and we'll do parent, and it's UDM. Open and close that item. And we'll do regex offset equals after parent and we'll grab the next one. So once again, we copy the data and we paste it. We replace these by that item, add a space, and then we close it again. Okay. So we've got the parent, which tells us where to look for the data, because once the data has been accessed by the decoder, it'll be trapped by the parent that matched to it. You then tell it to look at that, and you tell it to look down the line. So you look it out, and I forgot my brackets. So you add your brackets where you need them to get you the exact data result that you want. We close that up, and the best part of log test is if you have a syntax error, it will tell you. So you don't have to worry too much about that specifically. I just need to copy my sample data because I forgot to do that before I clicked out. And paste it in there. You see now it's not matching at all. And this is where regex gets tricky and people get frustrated. That's why it's important to use regex workbench and items like that. So now we need to troubleshoot why that's not working. And I just need to compare it. Outbound interface, out. We may have to add a space there. And ultimately, what you need to do is, if it still doesn't work, you remove your last changes and you try again. It could also be that I'm copying the data incorrectly. Let me just clarify that. Yes, I am. I am copying the data incorrectly. Take it from here. Okay, so it's definitely not matching. We'll revert our changes from previous. You don't have to remove it. You can do an exclusion. And you test it again to make sure that everything matches again. And this is the approach that you have to take. Don't become despondent. Sometimes logs act in a weird way, and Kelly's already spotted my mistake. So I'll fix that quickly. Yeah, it's the backslash. You see how quickly it is how easy it is to make a spelling mistake? or a syntax mistake. And your linter doesn't always show that. So we check. And now it's got my outbound interface, but not my inbound interface. So let me see if I've got a mistake there as well. No. And this is where it becomes important. It is also, if you have more than one team member, it is important to, or somebody that you trust that is familiar with this, to also review your code. It is very, very easy to make mistakes, and you don't want to be editing these on a daily basis. You want to create them, you want to create them correctly, and you then want to set them up in the environment. And the only time you want to touch them is if you want to change them for a firmware update or something similar. So while we're busy here, we can continue troubleshooting it further, or I can answer questions. The options is completely up to you. Managed to work through all the pertinent points. I've shown you some examples, and we can discuss it further from there. So while I wait for questions to come in, I'll play around with this as an example, just to see what the results are. Any questions? Okay, I'll take that as a no. Well, in that case, everybody, I bid you a great evening further, and thank you. Ah, there's David. Am I trusted to do this in the SIEMonster service? Yes, David. Yes, by all means you can. So let me make a deliberate error in the solution, and I can quickly show you why it's okay to work directly in the managed one. So let's just remove that there. If you run log test, you'll immediately see there's an error. However, if you look at the services that are running, you'll see that it's still running, and you haven't affected any of the running services. So the reason for that being is it will only apply your custom decoders and rule sets once you've restarted the OSSEC components of the solution. So, and that's why it's generally safe to do so. If you're really paranoid about breaking the system, it is very simple to spin up a Wazuh instance on its own, or the community edition, where you can play around with any of the items to actually see what output you can get. And yeah, there are various options available to you for that. Cool. Okay. Anybody else? Jason, Michelle, you guys seem interested in the decoders and the rules quite often. Any questions from your side? Okay, cool. What I'll do is I'll publish an example of the testing that I've done post this session, so that you don't have to sit for a few minutes or 20 minutes just watching me grind through the regex. And I will add additional notes to the slideshow to show where I found the gotchas and how I fixed them. And hopefully that will help everybody. Thank you for joining today's session.